Have you ever felt that incredible push back into your seat as a car launches forward? That stomach in your throat feeling at the top of a roller coaster drop? Or even just a gentle tug you feel when your bus takes a sharp turn? If you felt any of those things, then you have felt the central character of our story today. You have personally experienced one of the most fundamental concepts in all of physics. Today, we're talking about acceleration. Now, that word might bring back memories of a stuffy classroom and confusing equations, but I promise you, it's far more exciting than that. Acceleration isn't just a number in a textbook, it's the very language of motion and change. It's the story of how things go from still to fast, from fast to slow, and from straight to turning. So, let's start with a simple idea. Most people think acceleration just means speeding up. And that's part of the story, but it's only one of three parts. It's like saying a story only has a beginning. In physics, acceleration is defined as any change in velocity. And velocity is just a fancy word for an object's speed in its direction. So, if you change your speed, or you change your direction, you are accelerating. Think of yourself as the driver of a car. You have three main controls to change how you're moving: the gas pedal, the brake pedal, and the steering wheel. These are your three tools of acceleration. Let's break them down. First, the most obvious one, the gas pedal. This is the one we all know. When you're stopped at a red light and it turns green, you press the gas. Your speed changes from 0 miles per hour to 30, to 60. That change in your speed is acceleration. The faster your speed changes, the greater the acceleration, and the more you get pushed back in your seat. A sports car going from 0 to 60 in 3 seconds has a massive acceleration. A family car doing it in 10 seconds has a smaller, gentler acceleration. It's all about how quickly your speed is changing. Now for the second tool, the brake pedal. This might seem counterintuitive, but slowing down is also a form of acceleration. Remember, the rule is any change in velocity. When you press the brakes, your speed is changing, isn't it? It's going from 60, to 30, to 0. Physicists often call this deceleration, but it's really just a negative acceleration. It's an acceleration that's working against the direction you're moving. It's the feeling that pushes you forward into your seatbelt when you stop suddenly. So, hitting the gas is acceleration. Hitting the brake is also acceleration. Both are a change in speed. But here is the third one, the one most people forget, and it's maybe the most interesting, the steering wheel. Imagine you're driving in a perfect circle at a constant, steady 30 miles per hour. Your speedometer isn't changing. So are you accelerating? The answer is yes. Absolutely. Why? Because your direction is constantly changing. At one moment you're heading north, then east, then south, then west. Because your direction is changing, your velocity is changing, and therefore, you are accelerating. This is a tug you feel when you go around a sharp corner. That feeling of being pulled to the side is a feeling of acceleration. It's the same force that keeps planets in orbit around the sun, and the same force that keeps you on a merry-go-round. The object wants to go straight, but a force is constantly pulling it, changing its direction, and causing it to accelerate towards the center. So, to recap, speeding up is acceleration. Slowing down is acceleration. And simply turning is acceleration. Any of these three, or any combination of them, counts. So why is this so important? Why does it matter? Because acceleration is the bridge between just describing motion and understanding what causes motion. The great Isaac Newton figured out that accelerations don't just happen on their own. They are caused by forces. A force is just a push or a pull. When you feel that push back in your seat, you are feeling the force of the engine pushing the car forward, which in turn pushes you forward. When you feel the pull of a tight turn, you are feeling the force of the tires gripping the road, pulling the car in a new direction. Acceleration is the physical evidence that a force is at work. Without acceleration, everything in the universe would either be standing still or moving in a perfectly straight line at a constant speed forever. But that's not our universe. Our universe is dynamic. It's full of planets orbiting stars, galaxies spinning, and cars navigating city streets. It is a universe of constant change. And the language that physics uses to describe all of that beautiful, complex change is acceleration. It's the secret behind every launch, every stop, and every turn.